Hello and welcome. This is part 2 in a video series of how to get started with Pulumi and Azure and making it a piece of cake. In this video, we'll start by revisiting creating a new project and take it a little bit slower this time. After that, we'll spend some time showing you how you can get started creating new resources and some helpful tips that you might use later. Next, we'll go over the process for importing existing resources to be managed by Pulumi. And finally, we'll go over the topic of configuration drift and show you how you can handle it with Pulumi. Let's get started making a new project. Start with a new folder called Tutorial 2 and then head into a terminal and run the Pulumi new command. This will show you a list of project templates that you can start from that are separated by the cloud provider and then the language. There's a ton of them here, so let's just run Pulumi new Azure-Typescript. Now fill out the rest of the information needed for the project and create a new dev stack. Change the location if you need to, and then finish with installing the dependencies. This part's going to take a little while, so you should probably go ahead and have a break and maybe get a coffee or something. Now that everything's finished installing, let's start by taking all the code that comes in our default starter template, and let's just comment it out real quick. To be able to create any resources, Pulumi first has to have a stack in which it can write through all of the information that it's gathered about a given resource. So even if we have described no resources at all, we still end up with a single resource, which is the stack. And you can see that by running Pulumi Up here and it asking to create one. Now that it's finished running, we can go ahead and run the Pulumi Stack command to look at the information about it. We can see the owner, when it was last updated, what version of the CLI was used, a list of resources, and notice there's only the stack, and even outputs that we don't have yet, but will soon. At the top of our entry point file, we can see the code left uncommented is related to pulling in dependencies. These are import statements used to reference the node modules folders and find all of the code from Pulumi that helps us with our program. Now let's take a look at our first resource and uncomment this code here. We can see that we're setting a new variable resource group equal to a new object. And what we're doing is we're referencing the namespace from the import above, and we're using the resource group class to make a new object. If we hover our mouse over the resource group class, we can get a snapshot of all the parameters that it takes to make a new object. The first parameter that we have is the only one that's actually required and is a name for a given resource. It's important that this name is unique because Pulumi can't track two resources by the same name. It's also important to note that this value can only be a plain string. This means that it can't be an output from any of the other resources or a promised variable of any form. Some resources, such as this resource group, only require the name to be created. Arguments are always optional, but a lot of resources have required arguments that they need before they can actually get stood up. The options parameter is always optional, and this is used to control how Pulumi behaves with an object. This could be like making two resources depend on each other, changing the way it replaces objects in the cloud, and various other things. Now let's take a look at our storage count. We can see that it actually does have some arguments here. The first argument here is the resource group name. It needs to know this so it can create the storage count inside of it. And we'll notice that it is a Pulumi.output string type. This is basically saying, hey Pulumi, I don't know this value yet, but at some point I'll know it. Could you just wait around and figure it out? And this signals to the storage account that there's a dependency and it'll probably need to wait to get this name resolved. We can see by looking at the resource group name property that it is of the type Pulumi.inputString. This input and output relationship builds a resource graph for Pulumi to understand how to execute things as quickly as possible. By default, Pulumi runs in parallel and it tries to get as many things done at the same time as it can. But it always has to know, hey, this resource isn't ready for me to use yet, don't start doing other things, or else it'll get confused and step all over itself. We can see the other arguments here, such as skew and kind, relate to how you can control the storage account in the cloud. And there's a ton of other properties here too that you can list. If you're in VS Code, hit Control Space to see them all. If we continue down, we'll see something a little different than before. Here, instead of making a new resource, we're actually using a function to go and get storage account keys from Azure directly. And the last piece of our code here is using the storage keys to make a new stack output. Stack outputs are really cool and an easy way to share information with your team and others, as well as between stacks. Now let's clear the screen and run Pulumi Up. Pulumi Up is the main command that you'll use, and it signals to Pulumi that it's time to read through your program and figure out what to do. It takes a look at all your code and computes together a resource graph and the dependencies between them to put together an execution plan. You can take a look at this update plan, and if you're happy with what it's doing, you can click yes to continue. Now Pulumi will go through and create your resources in order that they need to be created and let you know when it's done. Now we can see the storage account key here, and that's been pretty handy for us, but let's go ahead and get some more information about our storage account name and resource group name. To finish creating our stack outputs, we have to run Pulumi Up. This will go back through our program and find the data that we need and create a new property on the stack outputs. We can run the Pulumi Stack command to see information about our stack. It shows us things like when it was last updated and gives us easy access to our stack output. This is super helpful for when you need to share information with someone else or run an Azure CLI command. Another super useful command is Pulumi Console. This will take you directly to your stack in the portal, and you can see your stack outputs, configuration, tags, and a lot of other information about your project. You'll also be able to quickly get to the README, check out the activity on the stack. Pulumi even tries to go the extra mile and gives you ways that you can start to visualize the resources you're managing. You can see them in a list view or even in a graph view here. Let's head back to our resource group and create something new. Let's search for a web app and create one. Let's fill in the information here and give it a name and pick a stack. Let's go with Node 16. You can change the location if you need to, or the plan. Click Create to review the request and create again to finish. Now the deployment is submitted and we just need to wait for it to complete. Once it's done, you can go to the resource and we can browse to see that it's up and running. Now let's look at the configuration. These are the things that get set by the arguments in Pulumi. If we head over to the pulumi.com/docs page, we can find an API reference section on the left. From here you can get to a lot of information about various providers, but we just need the Microsoft Azure one. We can see all the modules within this provider, and if we scroll down we'll find web. If we click on it, we'll see a list of resources. Now let's click on web app and take a look. You can see the documentation highly resembles what we find in the code itself. This is auto-generated and you have access to all of the inputs and the outputs so that anytime Pulumi makes a change, you have new documentation. The properties used with Pulumi resources are the same arguments that are used in ARM template definitions. If you come and look at the exported template for a given resource, you'll find all the properties match up with various properties on the documentation from Pulumi. Heading back to our program, we can see that the resources we've already created are defined in separate modules. So is the app service we need to make, so let's go ahead and make a new import for the web module. Now we can use the web import to go ahead and reference the web app resource to say that we want to make a new one. Go ahead and give it a name, and then let's look at the arguments. First we'll need to define the resource group name so that it knows to create it in the resource group. And then there's a bunch of other properties that we'll probably need to fill out. If we head back over to our ARM template, we can start to look at some of these properties and make sense of what we're going to need. Let's go ahead and copy the location and the kind. The location is probably already being set by the provider, but we'll add it anyway. And then let's go flip back and take a look. And there's probably more properties towards the bottom, such as all the site config stuff, and let's just take a bunch of it. So we'll grab a big block of properties and let's go paste it in. We can see after pasting all those properties that every single one of them except for this VNet route all enabled property is happy. If we take a look back at our ARM template, we should note the API version that's being used for this resource. Every resource should have a API version that it uses by default to create itself. We can see that the default version and the version we deployed don't match. If we head back to our project, we have access to change to a different version of the API by going into the namespace specific to that API version. This will make sure that Pulumi always uses this version of the API to make the web app resource. And now that we've updated it, we can see that it's no longer upset with us about the property that it didn't recognize. Now let's run Pulumi Up and try to create our web app. We'll get a preview and let's look at the details. Everything looks normal here, so let's go ahead and say we want to create the resource. This will fail horribly, and if you've worked with Appservices before, you should realize that we've made a mistake. We haven't told our app service about our app service plan. We'll need to manage this with Pulumi, but we don't want to disrupt the app service that's currently deployed. We can import existing resources by using the Pulumi Import CLI command. This command takes a type of resource, the name of the resource, and the ID from the cloud provider to know how to import the information about it. Let's start by getting the resource ID and heading to the app service plan in the Azure portal. Then we can go to the properties and copy the resource ID from there. Paste in the ID we just copied and put it in single quotes. Now we'll need to figure out the name. Let's go ahead and copy our web app template and then make a new app service plan instead. Give it a unique name, and then we can look at the resource properties, but let's see how Pulumi Import will help us with this process. Input the name from the resource above, and then the last thing that we need to find is just the resource type. This one can be a little bit tricky and hard to find out. One easy way to figure out what it is to go to the type definition for a resource and then head to where it's stored in the node modules. If you look at the plain JavaScript in the module, you'll find the resource type near the bottom. Copy the resource type and paste it into the command line, and then press enter to start the import. By doing this, Pulumi is going out to Azure and scraping all the information off of the resource by its ID. When it's done, you can look at the changes or you can choose yes to import. Once Pulumi is done importing the resource into state, you'll get a nice template kicked out that you can copy and paste into your code above. It should have all the properties that it was able to scrape that are relevant to this configuration. Go ahead and just replace what we already had. You may have to fix a couple things depending on the types of resources you're importing, but let's go ahead and update the resource group name too so that it's not being statically typed. Source it from the resource group.name property, and then let's go ahead and remove this protection. Every object that gets imported by default will be marked for protection so that you don't accidentally delete it. Now we can head back over to our web app and we can fill out the server farm ID, which points back to our app service plan ID. We can do this by calling the app plan object and using the ID property on it. With the resource imported and the new code in our project, we should be safe to run Pulumi Up at this point. It notices the difference in the protection and also wants to create the new web app. Go ahead and click yes to get it started. Now let's take a look at a different type of example. Let's consider that we have a coworker who had some issues getting something to work, and instead of trying to figure out how to make it work, he decided to disable security settings. But now we have our security team pinging us saying, hey, we have a vulnerability and I need you to remediate. First, let's see how Pulumi would handle this. Let's run Pulumi Up, and you'll notice that it actually doesn't have any changes. This is because Pulumi is referencing the state and not actually going out to the resource and checking what the property values are each time that it runs. We now have configuration drift between our resource and our infrastructure as code. This means that the properties we expect to be configured on the resource are different than what they're actually set to in Azure. As we saw earlier, this can lead to Pulumi not being aware of changes that it needs to make. Pulumi Refresh will go and scrape the APIs for the latest information. Once it's done updating, you'll get a chance to review all the information that it found out in Azure. You can look at the details closer and make sure that you do, because a refresh can trigger destructive actions such as a replace or a destroy. Continue with the refresh and you'll see that Pulumi updates the state successfully. You can run Pulumi up again, and now we should notice that it wants to manage the property. You can see in the details that it wants to set it back to true, and we can proceed with this change and finish the remediation. Running Pulumi refresh before you run any updates should be part of your regular activities to make sure you're always using the latest information. You can run refresh during an up with the -- refresh command to make it a lot easier. This will make sure that Pulumi is always running a refresh before you see any preview details. Now that we've wrapped up our lesson for the day, let's go ahead and run Pulumi destroy to clean up our workspace and delete any of the resources we made. Click OK to continue destroying things, and notice that there's 5 items to get deleted. Every service in Azure is described by its own set of API rules. Sometimes services will throw errors, and you'll be able to see them related to the service specifically. Here we can see the app service plan through an unknown error. If we head back to our portal, we can see that we forgot to delete our original app service, and because it's not in our project, it's not being managed by state. If we try to delete the plan, it tells us that it can't delete non-empty plans. So we're going to have to go back and manually remove this service from the portal. Go in and click to delete it, and then confirm it before heading back over to Pulumi. Now you can run Pulumi destroy again to start wrapping this up. We'll see that it only has 3 resources to delete this time because it was able to get a few before. And now it'll go through and finish deleting the plan and the resource group. The last thing that it deletes is the actual stack, and when it's done, you still have a shallow shell of the stack in the Pulumi portal. If you want to remove that, go ahead and run the Pulumi Stack remove dev command, and then you can completely get rid of any activity or metadata that's being tracked by Pulumi.
Thanks for watching. If you found this information useful and you'd like to support us in continuing to make videos like this, please hit that thumbs up button and subscribe to our channel.